You know, for the absolute brightest young math minds on the planet, there's one ultimate challenge. It's a global showdown of pure logic and creativity. It's called the International Mathematical Olympiad. And yeah, it's basically the Mount Everest of high school mathematics. But what if a totally new kind of competitor stepped into that arena? One that's not made of flesh and blood, but silicon and code. I mean, could an AI actually climb that mountain and take home a gold medal? Well, to even begin to answer that, you have to understand what makes this competition so incredibly hard.
So the IMO isn't about who can punch numbers into a calculator the fastest. Honestly, your calculator is useless here. These problems are designed to be just ridiculously difficult. They demand creative, totally new ways of thinking and multi-step proofs that go way beyond any formula you could memorize. And that, right there, makes it the perfect stress test for an AI's real ability to reason.
But there's a catch. If you want to train an AI for a challenge this big, you need a good way to measure how it's doing. And it turns out the old ways we used to test AI math skills, well, they're kind of broken. We're getting to this weird point where we can't tell the difference between an AI that's just making a lucky guess and one that's an actual genius.
A lot of the standard tests that researchers have been using for years, things like GSM-8K and math, have just gotten too easy. The top AI models are basically acing them. It's a problem we call saturation. And that's a huge deal because think about it. If all the top models get a perfect score, how do you know which one is actually getting smarter? It might just be getting better at remembering answers it saw in its training data. And this slide just nails the problem perfectly. See, on the left, the old tests only cared about the final number. That's it. Which means they might just be rewarding an AI for memorizing things. But the IMO challenge over on the right is a whole different ballgame. It demands these rigorous step-by-step proofs. It's not about the destination. It's about proving you understood the entire journey to get there. And that shift is absolutely crucial. So to solve this, a team of experts, and I'm talking actual former IMO medal winners, created a brand new set of challenges. They were designed specifically to push AI to its absolute breaking point. It's called IMO-Bench, and it's all about measuring what really counts: robust reasoning. So what exactly is this thing? Well, first, it's a whole suite of tests with problems at that insane IMO level. And get this, the problems were checked and approved by a panel of mathematicians who, between them, have won 10 gold and 5 silver IMO medals. I mean, these are people who know exactly what mathematical genius looks like. IMO-Bench is basically built on 3 pillars. First, you've got the answer bench. Think of it like a qualifying round. It just checks if the AI can even get the right final answer. Then you have the main event, the proof bench. This is where the AI has to write a full logical proof from start to finish. And finally, there's the grading bench, which is super clever. It trains AIs to grade other AI proofs, which helps the whole process scale up. Now, to make sure the AI isn't just, cheating by looking up answers it's seen before, the creators use this technique called robustification. It sounds complicated, but it's a simple idea. They take old problems and just change them up. They rephrase the words, switch the numbers, even throw in useless information, all to make sure the AI has to solve it from scratch every single time. And here's a perfect example. You don't need to be a math whiz to see that the problem on top and the problem on the bottom look really different, right? For an AI that's just memorized a bunch of problems, that bottom one is totally new. But for an AI that can actually reason, it can see that underneath the surface, they share the same mathematical heart. And that is how you separate the guessers from the geniuses. Okay, so we have this new, incredibly tough, cheat-proof benchmark. The stage is set. The question is, how did the world's most powerful AI models actually perform when they were put to the ultimate test? So let's start with that first pillar. Just getting the right answer. And on the IMO-AnswerBench, a model called Gemini Deep Think comes out with a commanding lead, scoring 80%. That's a really solid lead over the other big names. Getting an 80% on problems this hard is a massive accomplishment, but you have to remember, this is just the warm-up act. This proves the AI can find the destination, but the real question is, can it draw the map to get there? Because in math, and really in any kind of complex thinking, the final answer is only a tiny piece of the puzzle. The real prize, the true sign of intelligence, is being able to show your work and explain why your answer is the right one. And now for the main event, writing the actual proofs. And this is the moment that blew everyone away.
Just look at these results on the advanced IMO-ProofBench. Gemini Deep Think scores an incredible 65.7%. The next best model, it's all the way down at 23.3%. This is not just a small step forward, people. This is a colossal leap.
Look at that number, a performance gap of over 42 percentage points. This points to something fundamentally different in what this AI can do. It's the difference between a student who can just solve a problem and a student who deeply, truly understands the principles behind it.
So what does this all mean? I mean, it's super exciting for sure, but the implications here go way beyond some math competition. This is about the future of AI itself. You see, the real breakthrough here isn't just that an AI is getting good at math, it's that we're finally building an AI that can explain its own thought process. An AI that doesn't just spit out an answer, but can actually walk you through its logic, step by step.
And why should you care? Well, it all comes down to trust. If an AI can show its work, we can actually check it, we can verify it, and we can rely on it for much more important tasks. It means it can help us tackle huge, complex problems in science or medicine that don't have one easy answer. This whole thing signals a massive shift for the entire field. We're moving away from just getting answers to building AI with truly robust reasoning.
So, we're left with this really tantalizing idea. An AI has now shown it can't just find the peak of math's Mount Everest. It can actually draw us the entire map for the climb. So if AI can explain its reasoning in the purely abstract world of mathematics, what other complex, uncharted territories will it conquer next?